Live from New York, it's Ask This Engineer.
Hey everybody, and welcome to Ask Engineer. It's me, Ladyada the engineer. With me, Mr. Ladyada on camera control and behind the scenes, getting everything going. I could not do it without him. We got an exciting show for you tonight. So much news and updates. It's hot, so why don't you just stay inside, get yourself an ice cold glass of water or other favorite beverage, and hang out with us for the next 55 minutes or so as we go through all the news in the maker, hacker, engineer, coder, and creative communities that we are part of.
That's right.
We've got discounts, videos, new products, and more. Mr. Ladyada, why don't you tell them what's on tonight's show?
On tonight's show, the code is Expander, 10% off in Adafruit store all the way up to 11:59 p.m. Use this code, get free stuff on the way out, save 10%. And more. We'll be talking about some of our live shows, including Show and Tell, we just did a few moments ago. Do a little bit of time travel, look around the world of makers, hackers, artists, engineers, news that's going on, and more. From the mailbag, which is a slightly merged combination of chip shortage, because we're going to be talking about that. We got some made in New York City factory footage from the advanced manufacturing factory called Adafruit. We got some 3D printing. We got Ion MPI, brought to you by DigiKey and Adafruit. This week is Ablick. Got some new products. We got some top secret. We're going to answer your questions. We do that over in Discord, adafruit.it/Discord. Please hang out there and ask your questions here. We get to them at the end of the show.
Discord.
Discord is the way, because there's 5 different places the video's going, and the chat can only be in one spot for us to see. Join all 35,000 of us. We just hit 35,000 people in the Discord. It is a fun 24/7 maker hacker space that everyone is welcome to, including this show. All that and more on Ask an Engineer. Okay, so let's pay some bills to fund these skills. The code is Expander. Ladyada, when people check out in the Adafruit store, they get free stuff. What do they get?
We have all the freebies back. We're so excited to be back to our quad freebie selection. $99 or more, you get a Perma Proto half-size breadboard PCB, gold plate with beautiful silkscreen design. $149 or more, you get a free KB2040. This is a full microcontroller with 8 megabytes of flash and tons of RAM, STEMMA QT, button USB-C. It's castellated. It's Pro Micro shaped. It's great for any kind of microcontroller programming. And you can you get it free with your order. When you order from Adafruit, $199 or more, you get free UPS ground shipping in the continental United States. And back by popular demand, plus we actually got some boards made because we have parts that came in. Circuit Playground Express is back, $299 or more. You get our favorite low-cost, all-in-one development platform. The price of it has not risen 10%. It's the same as before, but you also get it free with your order. LED sensors and more. You can code it in CircuitPython, MakeCode, Code.org, Arduino, and many other languages. It's a very well-supported chipset and development board.
Okay, and a reminder, make sure you make an account on Adafruit.com, you verify your email, and then you set up 2-factor authentication, especially if you want to buy a Raspberry Pi. Usually Wednesday, Thursdays, we do a drop of Raspberry Pis. They're pretty rare. They're pretty scarce right now. We only allow 1 per customer, and you have to have an authenticated account. That's been keeping away the folks that were buying them and selling them on places like eBay for like $500, stuff like that. We've managed to turn the tide with that. Those folks aren't that happy, but their loss is your gain, so we have more Raspberry Pis that we're able to sell. So please do that. We do a bunch of live shows every single week. We do live shows.
We do live shows?
Yeah.
We do filming?
Yeah, we just did the show and tell.
And
this one was jam-packed, so make sure you go check it out on any of the places we publish videos. But it's always hard to pick a project, but I think I'm going to just say the highlight this week is if you want to get a free Python-powered tablet, you got to check out the project.
It's like a 7-inch capacitive screen.
Yeah, we're going to be giving away some in combination and friendship with K-March, and Joey, and that'll be part of CircuitPython Day. So really neat demos tonight too. You could see like multi-touch on these things, and these are basically heading towards the trash heap, but now they have a whole new life and they're running Python, CircuitPython specifically. So check it out. On Sundays we do Desk of Ladyada. This week we did something a little bit different because we were showing, Lamore's sisters were in town, so we went to a museum. So we decided just to do the Great Search. So we didn't have the entire time to do all of Desk of Ladyada, but we did fulfill our promise to help you find all the things on digikey.com. What was the Great Search this week?
Okay, this week's Great Search was, we use the APX 803 in so many of our boards as an auto reset power monitor circuit chip. It's a wonderful chip, but it's not recommended for new designs. And it's out of stock at DigiKey. And we have some on order, and we're going to get some, but I have to be ready to swap in an alternative. So we looked for some alternatives, and the big challenge is trying to get something with the same trigger voltage and also getting something with the same pinout. And it's tough because a lot of chips look like they're compatible, but they actually use a slightly different pinout. So I found two options. But if you're one of the many people who bases your hardware off of Adafruit hardware, you're going to notice that some of the parts that we've used traditionally are no longer available because of the chip shortage. Watch this other video to learn how to adapt your design.
Okay, and then we have JP's product pick of the week. That's where we broadcast live from inside the product page. So this week's product pick, JP, take it away.
My product pick of the week this week is the Minty Boost Kit version 3. So this is a USB 5-volt source that you can use to charge things like your phone or an iPod or your Zune player or who knows what, using just some common AA batteries. You get the custom PCB, you get the boost converter that takes your battery power, whatever it is, 2-3 volts, and boosts it up to 5 volts. We have some capacitors, an inductor coil, a couple small caps, and some resistors and a diode. These resistors are used to let an Apple device in particular know that it's okay to charge. Plug this in and you watch the charge up there at the top. When I plug that in, you can see it is now charging. So even though this is a super modern device, it is able to charge from the Minty Boost no problem. It is the Minty Boost Kit version 3.
Okay, and don't forget on Thursday there is JP's workshop. You can check that out tomorrow. And then during that time we have the CircuitPython Parsec with JP, and you'll be able to learn a little bit more about CircuitPython, including some of the projects that you probably saw on the socials. Friday we have Deep Dive with Tim. This is where you can see the innards of CircuitPython. This is Fridays at 2 Pacific, 5 p.m. Eastern. And with the current promotions that we're doing around CircuitPython Day, by promotions I mean just like, hey, come by CircuitPython Day, you'll be able to probably, if you're lucky, get one of these CircuitPython powered tablets. So check out Tim's
Free
show this week at Friday, because that's when we'll have more information about that. All right, time travel. A little bit of a reminder for time travel. We usually talk about AdaBox. We're still trying to ship them in August. We had originally wanted to ship our winter one in winter, but then winter turned into spring, and then spring turned into summer, and summer is now, and it's hot out.
It's hot.
And
that's why there's a sun.
It's technically a heat wave in New York right now because it's 3 days in a row of over 90 degrees.
Yeah.
And it looks like it's a scorcher.
Stay cool, everybody.
Yeah, so we're going to continue to try to get this AdaBox out. I'll talk about some of the chip shortage stuff soon. We're making headway in it, but this is a problem that everyone's going through. So thank you everyone who's been patient and understanding. Especially if you're like, hey, I really want an AdaBox. We really want to ship these AdaBoxes as well. So speaking of.
Letters. We get letters. We get tweets and we get emails. Your comments via.
Okay, so this week's a little bit different. So we don't have a chip shortage video or segment this week. So I'm just going to read. I thought this was kind of funny. So in the news, of course, and all the places like Hacker News and Slashdot and like other places, people
The kids don't know what Slashdot is.
Yeah, some of them do. It's probably good they don't. This is just a pull quote from people are saying, all these engineers are freaking out and the world's melting down and there's no chips. But we were kind of singled out, and they said it's gotten so bad that influencers are using cloud to beg for chips. And then they linked to
That's right.
our part shortage our series.
And it
then,
works.
Well, I thought there was a couple things that were interesting. One, you've been reduced down to being an influencer. And would it be great if like all these like YouTube and Snapchat influencers were begging for computer chips? They're actually not. They're doing other stuff.
It's just us.
But, you know, we don't really have clout. We just accurately describe what's going on. And that being said, we do beg for chips. And we're getting some chips in, but we do like to talk about what's going on. And I think sometimes when you see people say, hey, you know, you're doing this and you're doing that, it's because they can't imagine having to do this. You know, every single day we work a lot. And
I spend like 2 hours a day on chip shortage stuff,
yeah.
just trying to find alternatives and redesigning boards, and it's like pretty exciting.
But
I'm also a little tired of it.
I think it's funny, you know, it's funny to be like dunked on, like, oh, look at these like influencers using their cloud to beg for chips. But we have a big mission, and that's to get electronics and learning out to a lot of people. And so no stone shall be unturned. We will do everything. And I think it's important to look back in time one day and say, well, what was happening during that chip shortage? And we can point to each one of these videos and we could say, here's what we ordered, here's how long it took. And this is genuine. This is the real thing. This isn't, you know, we're not newscasters. We're right before the show.
We're influencers.
Yeah. No, we're real people that we work in an electronics factory. And, you know, we get asked all the time to quotes for the press, and, you know, they don't use them often because I think we're just gritty, boring people that are really doing this for a living. And so we don't have really any other advantages other than being as transparent and showing everything real time for all of you. So influencers are using their clouds to beg for chips. So we'll have another chip shortage video.
Successfully.
But one of the things that folks said was, that video series is really neat. That song is stuck in my head. And so I'm going to play it. Yeah, if you think that song stuck in your head, that's our life. All right, so let's do some Python on hardware. Okay, it is Python on hardware time. There's a lot going on in the world of CircuitPython, so I'm going to start off with that. Next month, August 19th, we are once again celebrating CircuitPython Day. We have an entire day's worth of activity. It's Friday, August 19th. We'll have stuff going on all during the day. We'll have show and tells. We'll have giveaways. Tune into all of the shows between now and then, and you'll get a chance to probably win one of those CircuitPython tablets. And then we have a full day of folks who are just doing cool stuff with Python on hardware. And so that'll be our CircuitPython Day coming up. Sort of big news, I think, anyways, because this is always interesting. This is the lead story in the newsletter, the Pi 5 RISC-V ASICs project. And this is an open source hardware chip, and they're making a community-driven, where they're describing it as a community-driven RISC-V based microcontroller with the ability to easily support CircuitPython and MicroPython. So, Ladyada, you know a little bit about these things. Why is this interesting, and is this the future of chip development?
It could be. This is interesting because, it's interesting for two reasons. One, RISC-V is a microcontroller architecture that has gotten a lot of attention lately because it's starting to be picked up by big industry partners like Western Digital. Makes chips with RISC-V, and High5 does as well, and a couple other companies, Espressif, ESP, and there's a bunch of other chip companies that are making RISC-V cores, and especially pairing them with machine learning and AI stuff. And usually with free cores, people do stuff like an 8051, which is an 8-bit microcontroller. Maybe you could expand it to 16. But the RISC-V is like a true, complete RISC architecture chip. It's 32-bit. It's quite advanced. It's got a full instruction set, and it's completely free. No royalties required, unlike the ARM Cortex series. And so, even though the RP2040 isn't explicitly designed for use with CircuitPython and MicroPython, there's a lot of design decisions they made that do make it a really great embedded Python chip. And so it's interesting to see, that's a dual core Cortex M0. It's interesting to see, can we make true, fully open source hardware that can run interpreted languages? And, I think people have come up with theoretical designs for the RISC-V, but I think they're actually going to try to manufacture and ship a chip that is specifically designed for, of course they'll be able to run other languages, but designed for running high-level languages using a fully open source from top to bottom
So
core.
theoretically, this could be one of the first truly open source hardware like laptops. Remember, like back in the day, there was Transmeta and like there was a lot of things for the old timers. But this is an open source hardware chip. It could run open source software like CircuitPython, and it's an interpreted language like Python, and the full stack from hardware to software could be open source.
Yeah, I think it's very interesting. The tough part is the peripherals, but if they've got the time and you can't get chips, you might as well sit down and do them.
Yeah.
It could be very neat. I think it is interesting that they're deciding, let's try to support MicroPython or CircuitPython. I know that I think the FOMU is an FPGA that runs a RISC-V core that runs Python, so it could be, or maybe it's the SOMU. I don't remember. They're very similarly named. But I think this is really neat. So check it out. I think they're doing some fundraising right now.
All right. So you can check it out on GroupGets, and also you can watch the progress on Hackster.
Banana for scale.
Raspberry Pi staff made some RP2040 lightsabers. They use Featherwing, CircuitPython, some 3D printing. We have some Pico add-ons. We're calling those bells. If you saw our video last week, we debuted cowbells, and you could see some of the logos and a little bit of the story behind
We
it.
need a song. We've got cowbells.
There's
Ding, ding,
more
ding,
cowbell.
ding,
I got a fever that only be cured by some more Raspberry Pi Pico Pi bells. And you can check out the rest of the newsletter with a gigantic, massive amount of projects. One of the bits of kudos we got that someone said is they called us a fair broker because we celebrate and have all types of Python on hardware, not just CircuitPython, not just MicroPython, not just desktop Python, but whatever people are putting Python on. And there's a few different ways to do that on devices, and we've written about this before. But all the projects. So if you're doing something in MicroPython, totally okay. If you're doing CircuitPython, it's fine. If you're doing some neat thing on desktop that has some type of interaction with hardware,
Throw it in.
send it over to us. We deliver this newsletter every single week into your inbox. You
No
can
ads.
also always check it out on the website if you don't want to subscribe, and that's over on adafruitdaily.com. It's a completely separate site because we don't like to mix up things like your store account and then stuff that you just want to read. So we decided to make a whole separate site, adafruitdaily.com, and that's just for newsletters. We don't spam, we don't market, we don't harvest any emails anywhere, anytime, but we wanted to go above and beyond and show that. Okay, we're an open source hardware company, and one of the things that we like to do is we really like tiny hot plates. Now, one of the things that we like to do is support other open source projects and developers. And so we have a guide on our website, which is kind of cool. And this guide, it says Anne, but Anne got the content from the folks that are working on the Iron OS firmware. It's this open source firmware that you can install on a mini hot plate. And if you're wondering how mini the mini hot plate is, that's how small it is.
It's so small.
And so what we said was, hey, do you want to do a guide around this? And can we pay you for it? Because we saw people putting this custom firmware on these soldering irons and then also these hot plates. And they said, yeah. And they said, hey, can you help support this project? So we donated directly to the developer. And the reason I'm putting this in the notes and everything is, it doesn't matter if you just donate $10 or $5, or let's say you can't even afford that. Email the developers and say, hey, thanks, I use this open source. I really appreciate it, because they don't usually get emails like that. They usually get pushy emails demanding, people are being mean. They're saying, oh, I need you to support this. I have this other thing.
Why won't you just?
Why won't you just? And I've never been treated like this before after being a jerk and demanding things. So, it's really hard to put your heart and soul into code and open source and not get a lot of watering of the flowers is the best way I can describe it. And if,
Do not step on flower.
yeah,
Water
and
it.
and if we want to see more open source and we want to see more cool projects, at least send an email. But if you can just, GitHub sponsors is available now. But this is a really cool project, and people are able to do more stuff. So the thing that we can do is one, support the developers behind it. But the other thing we could do is tell all of you about it, and then you could tell other people about it. And then you could say, hey, I noticed you do that, you like that open source project, or if it's comments online or if it's on Twitter, oh, cool, you use that open source project. Hey, here's a link to the developer page where they're looking for support. You don't have to dunk them, shame them, and say like, oh, how dare you, and don't support anybody, because I don't think that works that well. I think it's like, hey, here's a way to support them because it sounds like you like that, and you can see more things like that in the world. So anyways, that's why I wanted to put it in here this week. Okay. More open source hardware. This is kind of cool, Ladyada. There is yet another site where you put in a person's username, and it builds a city of their GitHub.
Oh, funny.
So this is yours. So this is the year so far,
Yeah,
and
'cause
it's
only halfway
GitHub
through.
City, and you
GitHub
put in
City?
your username, and then it starts to build a 3D model of all your pull requests
Yeah,
and contributions.
yeah.
And that's Ladyada City.
Oh, I like that we have a little like air,
Population, yeah.
little like air power.
Isn't that
There's
cool?
a mountain.
Yeah.
There's a beach.
All right.
Okay.
Adafruitville. That was from the chat. Okay, and then
Pull request built this town. I don't know.
yeah, and to prove we are an open source company, not only do we have the open source software, the hardware, but we have tiny heads that we squish
We
now.
squeeze. I'm
thi-
crashing your head.
Yeah, so this week's guides, we have a lot of fun stuff. Take it away, Ladyada, from the big board.
Okay, so, oh my goodness, what did we do? Okay, so the ESP32 S3 Feather Guide got a whippersnapper quick start page, so check that out. Kattni's been helping out Brent. We're adding that to all of our ESP boards. Don't forget, if you have a board that uses the ESP32 C3, S2, S3, or the original, or the 8266, Whippersnapper can support it, and you can submit a pull request to a JSON file that defines all the pins and the name and an image and stuff, and we can support your board as well. The MCP 9808 Precision I2C Temperature Guide also got a Whippersnapper starting page. We're trying to add some quick start pages. We have a lot of people who don't realize that we have a no-code way for people to do data logging and our IoT service, and since so many boards these days come with built-in Wi-Fi, especially like the Pico W, which we're
Yeah.
going to work on adding next. It's really great. It's like instead of data logging to an SD card, you can just data log to the cloud, which is our computer. Next up from Known Pedro, we've got a video that goes with this. You saw this. Hasbro's has a system that you pay for to create 3D
Yeah.
printed action figure selfies. But what if you could do it yourself using the 3D printer you already own?
So that actually looks like knowing. And one other thing about this, we mentioned this on Show and Tell, and you'll see this in the video in the 3D printing section.
Yeah.
But the new Thor movie has Natalie Portman as like a Thor-like thing. And
Yeah.
Pedro was talking about this, that I guess a dad and a daughter was in the toy store, and they were looking for that action figure of a, Thor-like
Lady
woman.
Thor, yeah.
Lady Thor. And it didn't exist.
The Mighty Thor.
And so, if you're especially a younger person and you don't see an action figure like you, it's kind of hard to imagine being that hero. So I think they're fixing it. Hasbro's trying to do this thing with some of the brands, and Disney's doing stuff, and there's a lot of things going on. But why wait? You can do this now, and if you have a phone, you can take photos. We show what app to use. And then you can either find someone with a 3D printer, go to a makerspace, send it off, and then you can take that little head and put it in the action figure. So you can make one of yourself. You can make one of that young kid who doesn't see an action figure that kind of looks like them. And then they can become that hero. So it's kind of a cool thing. So we saw this and we moved really fast on it because we're like, oh, that doesn't exist yet. The movie's out, but that doesn't exist. So we can make that. And I thought that was cool.
Yeah.
All right, what else you got?
Next up from Liz, she wrote up a full guide on using the NAU 7802. This is our strain gauge amplifier, which can be used for creating DIY scales. I thought it'd be cool to make a scale that fits, an existing Tupperware type thing, and it has a nice 7-segment display. The next step is going to be internetifying this to make it compatible with an online IoT service, so that'll be kind of cool. And then you can have like alerts come to you. But weighing things is a really common thing for sensing. You want to, if you can't measure how much water is in something, you can, from height or depth, you can maybe weigh the whole thing and it'll tell you how much material is in there. So in this case, it's cat kibble.
Yeah. Okay. And now it's time for some factory footage. See you on the other side. And it wouldn't be Main York City factory footage without a time lapse of the Disney. Speaking of Disney,
This is the second story.
now
second section.
they're building. It's going. This is where your Disney Plus subscription money goes.
Yep.
To building this tower across from Adafruit.
Yep.
All right, 3D printing. So we talked about that video that we have.
Yeah.
That Noah Pedro did of the action figures with print your own face on it, kid's face, other person's face. The whole idea is be that superhero you want to see in that world. And if they don't make one, no problem. You can make it. So we'll play that and then the speed up and we'll see you on the other side.
Hey, what's up folks? In this project, we're 3D printing selfie action figures. You can 3D scan your family members to make modified action figures. We scanned our heads and added a ball socket so we can snap fit onto existing action figures. These are printed in flexible filament and feature painted details like the eyes and hair. The built-in ball socket allows for articulation so you can pose your selfie action figures and have fun playing with them. These were a hit with the kids and we think these will make a great gift for the whole family. Most action figures feature removable parts and feature a ball joint for their heads. These aren't standard size, so you'll need to use calipers to measure the diameter of the ball joints. We used our phone to capture different angles of our head using the Polycam app for iOS. Check out the guide on the Adafruit Learning System for a full step-by-step tutorial. To capture a good scan, you'll want to get photos underneath the chin and the top of the head. Your subject will need to remain very still, so patience is really important. Also avoid wearing glasses, hats, or anything reflective. Once you capture a decent scan, you can export an OBJ file and import that into your preferred CAD program. We used Tinkercad to create a watertight mesh for 3D printing. Importing 3D scans into Tinkercad automatically closes any holes and repairs the mesh. We used a primitive cube as a whole to cut away at the model, leaving just the head. Position your cut right below the chin to avoid having to use support material. Our ball socket is made up of two primitives and joined together. These can be resized to fit the ball joint in your action figure. Position it right underneath the neck and combine the objects to create a ready-to-print scan. To bring out the details, you can paint on features using a dry brushing technique using various pigments. A fine pointed brush or toothpick can be used to add on small details like eyebrows and pupils. You can also mix different colors to match the character's bodily features. We printed several copies so that we could experiment with different pigments and painting techniques. We were really surprised how well these turned out with just hobbyist 3D printers. We hope this inspires you to try 3D scanning and making your own selfie action figures. Thank you so much for watching, and be sure to subscribe for more projects from Adafruit.
And you can make all this stuff or learn how to make all this stuff on 3D Hangouts every single Wednesday at 11 a.m. Eastern Time with Noah and Pedro, the longest running live 3D printing show on the planet. Okay, before we go over to INPI, Ladyada, the code is Expander this week. 10% off in the Adafruit store all the way up to 11:59 p.m. Let's do some INPI. All right, this week's INPI is from Ablick. What do they make? What do they do? What's a new product?
I'm glad I think this is our first time showing an Ablick or
Stay tuned. They got a cool video.
The video's pretty
you're
cool.
gonna like this.
So this is a Japanese IC company. They make a lot of timer chips, low-cost chips, RTCs, automotive stuff. We've never highlighted their stuff before, but I'm excited to show off something which I was actually looking for anyways when I searched on digikey.com/new. Somebody that asked for a chip like this, and this popped up, and I was like, oh my goodness, what a good coincidence. I'm going to show it off. So this is the S35 10 and 20 series of ultra low power timer chips. These are very interesting ICs that are designed specifically to be programmable with different wake up times. And they use an extraordinarily low amount of current, up as low as 0.2 microamps or 0.5 microamps of current. The one in particular I'm looking at is the 35710 series, which is the amount of time it goes to sleep for before it wakes up is programmable over I²C, which means that you can really set a very wide range of times from like 1 second to almost half a year. Compare that to, what we've used before, like the TPL 511 and 5110 series, which you have to use a resistor and it's a little tougher to use. This timer IC looks very simple, and I like that, of course, it's fully programmable over I²C. Okay, and it has a wide voltage range. So basically, what this is useful for is, if you have microcontroller boards like, the original Arduino Uno, or other boards that were designed early, or they're not designed for low power because they're using, say, a 7805 regulator and just the quiescent current on the regulator, not even including any of the other LEDs or buttons or chips or whatever, is already, 6+ milliamps. And you want to use this, you have your design and you want to turn it into a low power design, you may not be able to without like hot airing or desoldering components and replacing them. It might be actually harder than just adding a separate circuit to do the low power part. And also, historically with especially maker and dev boards, they weren't really designed to be used in final products or projects. They were kind of meant for prototyping, and then you'd go and design your own custom board, and if low power was important to you, you would pick the more expensive components as necessary. But what we're seeing is a lot of people are using off-the-shelf boards, like let's say you're using one of our Feather ESP32s, even though the ESP32 V2 Feather here, and that this chip, the ESP32, is a low power chip. It can go down as little as 170 microamperes, but you might want something lower power than that. Maybe you do want to get down to that 1 microampere or less. Or let's say you're using a dev board that's low cost and available, like the Pico W. Well, the RP2040 is, even in dormant or sleep mode, it uses, let's see, the typical current there is about 0.2 milliamps, which again is a lot higher than a few microamps. And, historically, again, this didn't matter as much. A lot of people were just happy to power something over USB or DC power. But then as people are doing more IoT projects or sensor nodes, there is this desire to, sleep for a few minutes, wake up, take a temperature measurement or look for a command, send the data over cellular or Wi-Fi, and then go back to sleep. So this circuit, this diagram shows specifically for this ABLIC IC, but the overall idea is pretty common, and we see this with especially the the ESP32 series, where you go into deep sleep for a few minutes, then wake up, fetch data, see if something's changed, activate a sensor or a servo or a motor or whatever, but you're not constantly checking. You're taking advantage of being in this ultra deep sleep mode. So that's where this chip comes in. So this timer series, I see, instead of having your regulator and your microcontroller manage your deep sleep mode and then automatically wake up, and you have this core that could be taking. This example here shows a 1 microampere. An STM32 or whatever, but even 1 microampere is extremely low for most microcontrollers. It's often tough to get less than, with a regulator especially, less than like 50 or even 10 microamperes. But with this chip, you might be able to get under, 0.3 microamperes total. And, in this case, I even show with an LDO, but because this chip runs from 2 to 5 volts, you might not even need an LDO. I think if you're running off of a LiPo battery or a couple AA's, you can have the timer IC run directly from your battery power, basically having almost no current. And if your sleep times are very, very long, if they're, minutes or days or hours, this will let you run off a battery even longer than, maybe 5 times as long as you would by using the built-in microcontroller's deep sleep. So this is the block diagram. So how it works is you do have to get a crystal, 32 kilohertz crystal connected to the X in and X out. You power it with VDD and VSS. There is the I2C connection, and again, that's how you tell it how long you want the delay to be. When you toggle the reset pin, it will start from 0, start counting up 1 per second. It has a 24-bit timer. When the timer matches the counter that you set, the int pin goes low, and that would enable your regulator or fire an interrupt or reset something, whatever necessary. And then your microcontroller would do whatever it needs to, and then when it's ready, it would toggle that reset pin low. And when the reset pin goes low, int will go back high. It'll shut down the rest of the circuit and start counting again. So you basically you trigger that interrupt pin on the set timeout, and then you wait for the microcontroller to tell the chip, okay, I'm done computing whatever tasks. I'm going to go, put me back to sleep and wake me up in, 60 seconds or 5 days. There's also a version of this chip that comes with a crystal built in. So there's two packages. There's like the MSOP package, which is low cost, about $1, and then there's the version with the crystal. It's a little bit more expensive because it's got a crystal bonded in. But you might want that for convenience, so you don't have to wire up a separate crystal. Otherwise, the circuitry inside is otherwise identical other than the crystal. This just shows the block diagram for the version, the M series version, again, with crystal built in. You can see the quartz crystal is just bonded in the package. Otherwise, though, it functions the same. There's also another version of the circuit. So the I2C version of this chip, again, you have a 24-bit counter. 2 to the 24 seconds is 194 days. So you just tell how many seconds you want it to be in this ultra deep sleep. There's also the 35720, which has two, instead of I2C, it has 2 GPIO, and you can just patch those high or low. You see on the bottom right there for 1, 10, 30, or 60-second delays. So if you don't need very long delays, if one of those times those amount of times is good enough for you, you don't have to do the I2C stuff. It'll just automatically do it based on whatever the pins are strapped to. As mentioned, the current consumption is ultra low. Because there's no microcontroller core, it's just like a counter basically. It gets down to as low as 0.2 microamperes. If using a 6 picofarad load capacitor, max is maybe 0.5 microamperes. So ultra low consumption. Nothing's going to beat it. And if you're tired of trying to optimize the rest of your circuit, you can throw this in or you're using modules that you can't change the regulators, you can't change the chips, or maybe the chip you want is unavailable because of chip shortage, toss this in and it'll solve your low power problem. For I2C, it's pretty simple. There's basically, you can read the time register against this counter that counts up over time. And then you've got a matching wake up time register that you write. When those match up, the reset occurs. So I like the I2C version. I'll probably just make a breakout with an external crystal. But very promising. I love the TPL series. A lot of times people are like, I want to make something low power and I'm struggling. And I'm just like, you know what? Just add an external timer chip and it'll do everything for you.
Available on DigiKey and it's in stock. And
that's right. You can actually get it.
And that's one of the challenges with Ion MPI. We want to make sure if we're going to get excited, get you excited, get everyone excited to use some of these things in your projects, that it's available. And special treat, they have a really cool video, so we're just going to play it.
You didn't see that
All right.
coming.
Yeah. So, what's funny is there's a lot of cool companies out there that make amazing chips, and they have amazing marketing. Like, that is like
That's
kind
pretty
of
cool.
our style. Like, we have our own album too. So I'm hoping one day maybe there could be some type of Chipapalooza where all the electronic bands can get together.
I just like that they didn't have like the standard like at Ablick we
We
invent the
inno-
future by
we
innovating the
innovate.
past. It's like okay,
We innovate by the innovators for
Yeah.
innovating.
okay.
Yeah. All right, let's make sure folks know the code. And then let's do some new products. Codes Expander. And you ready, Ladyada?
Yep.
Let's do this.
No, 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 no. No, 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 no. No, 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 no.
All right.
I don't know.
So,
It was a catchy tune.
It was good. So first up, it's not a new product. It's just a back in stock,
Back
which
in
is just
stock.
as important. We got the microbit bundles.
Microbit V2 Go bundles. We got a shipment of them.
We-
I think we still have some in stock.
We do have a limit of 5 per customer because educators been waiting for these for a really long time. A lot of them switch over to circuit playgrounds, but that's okay. We have these if you want them.
Pick them up.
Next up,
Okay, we've got 2 of these ultra skinny UTP cables. So, these will work for Cat 5 use with Ethernet, like gigabit Ethernet or 100 megabit Ethernet. But I'd also know people tend to use these RJ45 connectors for DIY projects when they have to get 8 NeoPixel signals over from one side to the other. And so, wanted to have these ultra skinny cables. Of course, the connectors are still kind of chunky, but the cables themselves are only 3 millimeters. And if you're okay with not having full metal shielding on the cable jacket, then these will fit around and curve through your project much more easily. So we have these in both a 1 meter and 1 foot length.
okay. Next up,
Next up, you get some old projects with an RS-232 connector on them. We now have an FTDI cable that has USB-C on one end and RS-232 on the other. Inside is an FTDI FT232RL cable plus a level shifter converter slash charge pump that will take the 5-volt signal and convert it to plus minus 10 volts. Some lower cost cables don't give you the full plus or minus. They only go from like 0 to 10. And it'll work sometimes, but this one actually goes from negative at least 6 to positive at least 6. It's also using the FTDI chipset, which is extremely reliable and high quality. It's got drivers for every operating system. So if you're trying to connect to some old equipment, or maybe you just want to get your Palm Pilot up and running again with your M1 MacBook Pro, this cable will definitely do the job.
I'm gonna tell everyone this is the new lightning cable from Apple.
Yeah.
I'm gonna it's called drop lifting. I'm gonna put this in the Apple store.
Yeah.
And just say like
We have to get a white one.
new lightning cable. Okay, next up.
Okay. Next up, by request, JP wanted us to get some good-looking knobs.
Yeah, so we got
so we have some
a
good-looking
few different colors, and
knobs.
this is just the top view.
Top. So we've got gold is best,
Gold is best.
cherry red,
Yeah.
blue steel, silver fox,
Is that what we're calling it?
yeah,
Yeah.
and Adafruit black. So 5 colors. These are machined solid chunk anodized aluminum knurled knobs. They feel great. They're 20 millimeters wide. I'll show them on the overhead. By 15 millimeters tall. They have a set screw. If you go to the next image, just
Yeah, I
to
was gonna
show.
say that's kind of
Yeah, it's a
like
set
the
screw.
best part of these.
Yeah, so the reason that it's great that they have a set screw is that the inside, as you go to this image here, the inside is a 6 millimeter drilled out core with a set screw, which means that you can use it with rotary encoders or potentiometers or really anything like that uses a 6 millimeter shaft, which is kind of standard, whether it's D, T18 or round shaft, and then you just use the set screw to set it. So it's kind of a universal potentiometer rotary encoder knob. I mean, these are great. These are sometimes used in very nice, guitar pedals or guitar mods or synthesizers. But I think they just are a very high quality knob, and I like to have nice knobs. Sometimes that finish really makes your project stand out. So I can show these on the overhead.
Yeah, go for it. I'll keep showing these photos until you
So
you get there, and you're there.
Okay. Okay. So, so it's gold, silver, blue, and then where'd the red one. Okay. So yeah, these are, so now you can see the scale because you've got my fingers
Yeah,
in the way.
a human hand.
Human hand, and then I also have a potentiometer. So this is like a T18 knob. So you can see here the set screw. So this fits in, nicely. You adjust it the way you want. And then this is a 2mm hex wrench. You just crank it down, finger tight, and then now you've got a nice knob with an indicator. This one has a black paint, but the rest one are white paint, and they look really cool and they're beautiful. They're anodized, so they're durable, and they've come in these beautiful jewel tone colors. So thanks, JP, for recommending them.
All right, the star of the show tonight, besides you, Ladyada, our community, our customers, our Adafruit team, and everyone who helps make this thing go, is
A new breakout, the PCF 8574. So this is a STEMMA QT breakout for an I2C GPIO expander. If you've been watching our shows, we can't get the MCP 23017 or 08 series GPIO expanders. I love them, but they're not available. So I thought I'd expand my, outlook and find some alternatives. So the PCF 8574 is a low-cost expander from TI, and it's available, which is the most important thing. It's got 8 pins. You can control it over I2C. One nice thing about it is it has 3 address pins on the back.
You want this one?
Yeah, in the back. So you can have up to 8 of these connected. The default address is OX20 hex, but you can have 8, so that's like 64 total GPIO. It's got STEMMA QT, so it's plug and play. So what's interesting about this chip, I do want to mention, because it took me like a few minutes to grok what's going on. It's extremely simple. There's drivers for, we wrote drivers for Arduino and CircuitPython, but honestly, it's such a common expander. You're going to find drivers for almost any platform. You basically read and write just 8 bits directly to the I2C address, and there's no specific direction pins. So what you're used to with most I/O expanders is you have a direction, and then you can also set pull-ups. So you can have the input, and then the input can be high or low, or the output high or low, and then you can add pull-ups as well. So this chip doesn't do that. Instead, it actually has 2 modes. So each I/O can either be an input with a very weak pull-up, about 100K, or an output that's sinking current. And what that means is that it basically can act as a bidirectional I/O. If you want it to be an input, you turn it on with that weak pull-up, and then you can, by default it reads high, and if the whatever signal is sent low, you read low. And if it's floating, it reads high. So if you have a button, for example, I'll show this on the overhead. So I have 2 I/Os here, because this is actually the most confusing is buttons and LEDs. Note that I didn't have a resistor with the LED because I'm just I'm being cheap and fast here. So the button goes between ground and the I/O number 1. You cannot connect a button from an I/O pin to high. There's no such thing as a pull down. There's only this light built-in pull up. But when I press this button, it can detect that I'm shorting the input to ground. And then what it'll do is the code running in Arduino on this Cutie Pie reads that through I2C and then writes P7 to be that output low. So if you want to read an input, you basically have a built-in pull-up, light pull-up. If you want to drive an LED, like something that's really sinking current, the LED has to be connected from positive, the anode to positive, and then common cathode. So you ground the LED to turn it on. If you try to connect this LED from the output pin to ground, there's no such thing as sourcing current. You can only sink current. It only matters, again, with an LED. You can only connect it from high to the GPIO, not the other way around. And a button, you can only use that built-in light pull-up. If you're using signal, like you're using this to trigger a reset pin or communicate with another digital circuit, that light pull-up will always signal a high voltage, and turning it to an output low will signal low voltage. So as long as the input impedance of whatever digital circuit you connect it to is greater than 100K, which is almost everything that does digital circuitry, other than very old TTL logic, this will work just fine. It's just a bit of a funkiness. You can think of it basically as a open drain I/O expander. That said, it works quite well as long as you're just aware of the button and LED situation, the way you have to hook them up. It's extremely fast because there's only one register, and it works with a wide range of voltages and a wide range of I2C frequencies.
And
that's new products.
And that is new products.
New.
Okay, so don't forget the code is Expander, and we're going to answer some questions. Please go over to Discord. I've got the ones lined up that you've already put in the chat, but we're going to do some top secret, and then we're going to go over there.
Okay.
We've got a couple things from Top Secret.
Get
This is
in the
from
vault. What's
this is
going
from
on?
a couple days ago. So
Yeah.
I hope you remember them because you made them.
Oh, okay. So this is the TCA 9584. So we already have a breakout for this that doesn't have stemma QT, but we've had enough people ask us for stemma QT. And also I had the idea of having a logic level shifter so you could connect this to like an Uno, and then the client's, peripheral I2C devices could be 3 volts instead of, 5 volts. So I thought that could be kind of useful. So it's a little basic breakout with 8 QT ports.
Next up.
Next up, like I mentioned, the MCP 23017 is really hard to get. But the SX1503, which we showed off on a great search a couple weeks ago, is not hard to get. It's available. It's also 16 GPIO. Couple trade-offs. There's no address select, and there's only one IRQ, but it has a kind of a funky voltage level shifting capability, which allows you to, when you're doing the I/O expansion, you can use it to interface with like as low as 1.8 volts or as high as 5.5 volts, and it's 5 volt safe. But also again, for a lot of people just using it for buttons and LEDs, it'll work very similar to the MCP 23017. So I designed a very similar breakout board, almost the same size.
And that's Top Secret this week. We got more next week. We have a backlog of Top Secrets,
So many.
You'll see them soon. Okay, so we're going to go over to Discord. Just a little reminder, we're up to 35,000 people. Thank you, everybody. A lot of people like to share their project and smarts with one another in a cool, safe place, like our Discord, adafruit.it/Discord. Okay, so Ladyada, I have some of the questions lined up.
So yeah.
And then this week I have a thing I think might help you out, because some of these questions, I'm just reading the stuff off the screen, so you can do this.
Oh wow.
Yeah, so if you want to repeat some of it, I'll
amazing.
get the word out. But
Technology.
this is from ISO 213. I have a thermistor hemostat with 8 wires, 2 for 24 volts AC, 2 for ground, 5 volt DC, and then the other 4 wires are paired signal and ground. For both temperature and humidity, how would you go about determining the protocol used on the signal wires?
With 8 wires, 2 for for ground and DC. So there, the power wires. And then the other 4 wires are paired to signal and ground from both the temperature and humidity. It's probably 4 to 20 milliamp current, which I've actually never really interfaced with. But it's called 4 to 20, 4-20, and that's probably how it's actually sending like a constant current signal. So it's a little bit protected against, noise in the voltages. So it's probably syncing or sourcing that current, and then you'll need to use a converter to convert that into a voltage. But that's just a total guess. You might also just type in your thermistor or hemostat part number and see if other people have interfaced with it.
Okay, this one is a kudos. The mag tag deep sleep works so well, it's mind-blowing.
Yes.
Okay, please tell me that you'll make a breakout for this S35710M timer.
Yeah, I did
see.
design one. Well, I haven't finished routing it, but I did do a quick design for one.
Okay.
I think it's cool. It is a really interesting, cool chip. Only thing to watch out for is, I made it stemma QT, but you always need to connect the the reset and interrupt line. So it's not like it's, you still have to connect some more wires. It's not fully, all in one.
The other question was, you want to break out also a Adafruit library for simple code scripting, and how about a second breakout that goes to a MOSFET so you can connect and toggle higher power devices if I'm not mistaken, that's
it's like
the
a
other
high-
way is for an interrupt.
Yes. You could do, yeah, I could see, maybe I can figure out a way to fit that into the PCB as is.
Okay, and then for the 8-port I2C expander, it says it'd be great for projects like Adafruit IO and Whippersnapper. And then someone said, wouldn't the pull-up make it glow faintly?
No, it's very weak.
Okay.
Really, I tried. It's an ultra weak IO. It's a very interesting, weird chip. I'm like, did you really, to save that much money, you couldn't put like another register in? But this is how they designed it. That said, it really does work.
Yeah.
It does work as long as you're aware of this weirdness.
Okay. And then I saw you had a Pico Metro, Pi Pico Metro. Do we have a GitHub repo for that yet?
No, it's
not out yet, don't ask.
oh my god, there's so much stuff that's not done. Okay.
There is a lot. It's hard because you work on a design and we can't manufacture it because there's just like one, like even if you get 99 parts for it, one of the parts is not around, so then you have to move on to the next one.
Well, it's also, we have so many, we have 400 plus products that we've already made, and I want to make sure that those are still stocked. So it's like, it's tough because I'm constantly updating, like every day, every week, I'm revising and updating products to make sure that we can continue to stock them. And as we're doing this, like suppliers are going out of business, or they're discontinuing things, or we order something and they say they're going to ship it and they don't ship it, and then like we're waiting and like
this ain't for the faint-hearted. Hardware is getting hard, everybody.
Yeah.
The days of just ordering stuff and it showing up next day are over. They may never return, but we'll get through it. We thank everybody for supporting us during all this
We have
being
knobs.
patient. DJ Devon 3 says the MagTag has been running for 32 days now. Still going strong.
Yeah,
People
no,
have them going for 30 or 40 days.
I did design the MagTag to be
It's incredible.
low power.
I don't have anything that works for 30 or 40 days. I don't even work for 30 or
I'll
40
say,
days.
it's another thing that's interesting is, the designs that I used to do were not low power because I personally just never cared about low power. And it was just like, well, I'm just like, let's just get the design done. And then people started to care a lot about low power stuff, which I get. There's more IoT, it makes sense.
Yeah, then we get that cool power monitor thing.
And I got, power monitor. But so you'll see a lot of, and I started just like, I'm like, okay, I'm just going to learn how to do it. So I made a couple of mistakes on the way, but I've learned like a lot of tricks on how to do low power stuff. So all of like the feathers and the
watch our
cutie
shows.
pies.
We actually show people.
Yeah, I've really revised, how, like, and another thing is, as I'm doing board revisions because of part shortages, I'm like, well, if I'm in there anyways, I'll gut things around and I'll also make it a lower power design.
Okay. Well, that's the questions, and that's our show for tonight, everybody. Thank you so much. We're kind of exhausted. We're going to get out of here. But just a reminder, the code is Expander. That gets you 10% off in the Adafruit store. Don't forget, you get all of this free stuff as you check out. And don't forget to authenticate your account. Special thanks to Zay and the Adafruit Slack, who's running things behind the scenes. Thank you, Zay. We'll see everybody next week. Thanks for making this a lot of fun and having something for all of us to look forward to do each week. So we'll see everybody next week. This has been an Adafruit production. Here is your moment of Zener. We'll see you
Thanks,
next
everybody.
week, everybody. Thank you.
Good night.